So let's go to the actual linked list program. Uh, See here the structure is same. We have one member that is the integer member, and we have one self-referential pointer. And let's come to the main program. Just declaring one integer variable as a choice, and end pointer is assigned with a null. New one temp pointer I have extra for future use. In the while loop, I'm just like displaying the linked list menu. So in the menu, as of now, we have three choices: add node, delete node, and the display. Okay. So now we are asking the user to enter the choice. Let's assume user is giving the choice as a 1. That is add node. So it means switch 1. It will go to the case 1. Okay. Now we are trying to create one new node. Okay. So for that, I'm using this new pointer. Got it, right? The new pointer I'm using, and in the new pointer, I'm just going to first what we have to do, we have to allocate the memory, right? So allocate the memory. New is equal to struct student star malloc size of struct student. Got it, right? Okay. And now the memory is allocated, and you get the details from the user, that is roll number, and fill it in the first one. So let me go from the beginning itself. So you have a pointer, and now you allocated the memory for first student, that is you have a new pointer. This is 1000, and yeah. So it is assigned with, as of now it is none, correct. Now the new is assigned with what? The base address 1000, and fill the details. Fill the details means printf enter student roll number and scanf %d. So directly you can receive it on the this one itself, or you want some temporary variable, you can use like a d. So you can receive it in the d, and whatever you received the roll number, that you assign in the new. So how to assign? New arrow roll number is equal to d, and new next will be
arrow next
equal to null. That's all. Clear, right? Okay. So it means now new is 1000. So here you will have a roll number. Let's take like a roll number is 10, and here it is assigned with the null. Clear, right? Okay. And now you need to check whether this node is the first node or already some nodes are there. But according to our explanation, this is first node. But how do we make sure this is first node?
Ed equal to null.
Very good. If ed is null, then this is the first node. Got it, right? Everybody clear, right? Okay. So if ed equal to null, then whatever we created the new node, that will be the first node. So you go inside. Now this node you want to assign it in the ed. Ed equal to so in ed what will be assigned? 1000 will be assigned. Clear? So everybody following, right? and close this. And assume that like we are closing the switch here. We have a break here. And we are closing the while loop here. And we are closing the main here. I'll come back. Okay. So now one node is created. After that you have a break. Break means it will come out of switch because it is inside the switch. So it will come out of this switch. Again, where it will go? Again it will go to the while loop. Again it will display the menu. Again it will ask add node delete display. User getting the choice. Let's assume again he is giving the choice as a 1. So now again it is given as a 1. Switch 1. Again it goes here. Now again new node will be created. Okay. So now what will happen? Again one more node is created. Now let's assume this is at 2000. Now 2000 assigned where? It is assigned in the new. Got it? And you are asking the enter student roll number. Now user is giving another roll number. That is 11. 11 you are storing a new roll number. So 11 is stored here and here is assigned with the null. So far everybody clear? Okay. Now you are checking 8 equal to null. Now condition will be failed. So you have to go to the else. Now you have to write the else function. In the else function what we have to do? We have to attach this with this. Okay. So then let's remove this. So let's write else. In the else, whenever it is going to the else means already we have at least one node. Okay. But how many nodes that we don't know. Got it, right? So as of now we are assuming that like this first node is there. But yeah, since we are writing this program now, like we know that sir already one node one is there. But assume that already 5 node is there also, like the if condition will fail. Already 100 node is there also, if condition will fail. Now whatever newly we created the node, that node has to be attached with the last node. Now we have only one node, so this will be the second node. Now if we have 10 nodes, this will be the 11th node. Got it right everybody? So what you have to do, you have to find which is the last node. So how we can find the last node? We have a null. For identifying the null, you have to do the traverse. Okay. So let's take. Already we have one temp pointer. So temp you are assigning 8. Is it covering? Covering, right? Okay. So temp you are assigning the 8. It means you have one more pointer. That is temp. In temp, what you are assigning? The 8 you are assigning. 8 whatever you have 1000, that 1000 is assigning the year. Okay. Now, while temp arrow next not equal to null. Inside this temp is equal to temp next. I'll tell you why we are doing this. Okay. See now 8 is 1000. 1000 is assigned in the temp. Okay. So now this is temp. Here you are going temp next. Temp is what? 1000. 1000 next. 1000 next is null. So 1000 next is null. I mean this is null. Null not equal to null. Condition? Condition false. First time itself condition false. So it will come out of the loop. See this line is inside the loop. So it is coming out of the loop. Now see, when it is coming out of the loop, it means that you are in the last node. Temp is pointing at the last node. So whatever the new node we have, that node has to be attached with the last node. Okay. So now you try to attach the new node with the temp node. So we can attach temp arrow next equal to new. Very good. Anything else you need? Look at here. Temp next. In this place, what you are assigning? You are assigning new. New is what? 2000. Is that clear for everybody? Okay. So now end is pointing 1000, 1000 is pointing 2000, and this is the last node. So last node is pointing the null. Now again, you assume that after completing this, break is there. So it will come out of switch. Again, it will go to the while loop. Again, display menu displayed. Add node, delete node, display. Again, user is giving choice 1. Again, it is coming to the case 1. Again, you are creating a new node. Now let's assume it is at the 3000, and this will be 3000. And after that, you are asking the user to give roll number. So roll number user is giving 12, and the next is assigned with the null. And after that, you are checking end equal to null. End is 1000. So condition fail. It will go to the else. And here end is 1000. 1000 assigned with the temp. So now temp will be having 1000. It is coming to the while loop. 1000 next. 1000 next is 2000. 1000 next is 2000. 2000 not equal to null. Condition true. True means it will go inside the while loop. Now temp is what? 1000 only. 1000 next is 2000. 2000 updated into temp. This is very important place. See, temp is nothing but 1000. 1000 next, that is 1000 next is 2000. So 2000 you are assigning into the temp. So temp will become now 2000. It means the temp pointer is pointing the second node now. Previously it was pointing the first node. Now it is pointing the second node. Now again loop will go. Now temp is 2000 next. Null. Null not equal to null. False. It will come out of the loop. Now temp is 2000. 2000 next. 2000 next. Here null is there. In place of null, you are writing with the new. New is 3000. So 3000 will be replaced. Got it? Okay. Again break will be there. It will come out. Again it will go to the menu. Again user is giving choice 1. Again it is coming here. Again it is creating the one more node. Let's take this is 4000. So this will be updated with the 4000, and the roll number, let's take it is 13, and this is assigned with the null, and the AD you are checking, AD is 1000 equal to null, condition false. It is coming here, 1000 assigned here, 1000 next 2000, 1000 next 2000, 2000 not equal to null, condition true. It will come here, 1000 next 2000 is updated to the temp will be 2000. So now temp is pointing at the second node. Again temp next 2000 next 3000 not equal to null, condition true, come here, 2000 next, that is 3000 assigned into the temp. So now temp will be pointing the third node. Again 3000 next. 3000 next. Null not equal to null condition. False. It will come out. 3000 next. In that place you are assigning the new. So new is 4000. So 4000 will be assigned the year. Is that clear? Okay. So this way, new nodes are keep added one by one as per the need. Now, how many students you want? Only that many times you are going to call this add node. You want 5 students? Only for 5 students we are allocating memory and we are adding it. You want 1000 students? 1000 students only you are going to add and keep it. So we are not going to allocate even extra for one student also. As per the need, dynamically we are allocating it. Okay. So this is fine. Now, whatever you created, that you want to verify. Sir, whether it is created properly or not. So that you can call the third function, third case. Display. So the display, what it will do? It will display the student details in a order, like from the first node to it will display the till last node. Okay, let's write the display function. Fine, right? Let's continue, right? The same way. Okay. So the display function is like a case. So you guys please continue here in the same order. Okay. Since I don't have space, so I am just here printf. Okay. First, see whenever you go for the display function, see the user can call this display function even if no nodes are created. That time also there is a chance that he will give the choice 3. That is the programmer responsibility. He has to give the proper error message. But you didn't create any node at all. Correct, right? So first thing is what we have to do. We have to do the proper check. Any node is there or node, at least one node is there. I mean, at least one node is there, you can display. But no nodes are there, then you cannot display. So that you have to inform. So how we can verify that?
Head should be null.
If head is null, very good. If equal to null,
Then no node is
then printf
empty list.
list is empty. Got it? Else, then at least you have one node. Okay. So now we have to write the proper display function. Else, here again you use temp. Head is assigned with the temp. While temp next. Okay, I am not using next. You will understand the reason. Temp not equal to null. Inside this printf %d /t temp roll, and then temp is equal to temp next. Close this and give break. Is it clear? Okay, let's understand. See, is this part clear for everybody?
Yes.
If head is null, you don't have any node. So that like just head equal to null means you are just giving a message that this list is empty, and then it will come break and it will go to the again menu. Okay, let's assume it is going to the else case. Let's take this scenario. If it is going to the else case, then what we are doing? Head we are assigning in the temp. So the temp is assigned with the what? Head is 1000. Now you are going here. Head not equal to null. Head is 1000 not equal to null. Condition? Condition true. 1000 not equal to null, right? True, you are coming inside. Now temp is 1000 roll number. 1000 roll number is 10. So you are displaying like a, maybe here you can put one message. Here you can add one message, printf list data, like that. So it will come like a list data, and in the next line it will print first roll number is 10. Got it, right? 10 and slash t we are given, so that it will go to the one tab space. After that, temp next. Temp is what? 1000 next is 1000 next is 2000 updated into temp. Now temp will be 2000 not equal to null. Condition true. Come here, 2000 roll number. 2000 roll number is 11. So it will display 11. Next, temp is 2000 next is 3000. 2000 next is 3000, right? 3000 updated into temp. 3000 not equal to null. True. Come here. 3000 roll number. 3000 roll number 12. And then 3000 next. 3000 next 4000 updated. 4000 not equal to null. 4000 not equal to null. Condition 4000 not equal to null. Condition true only. Going here, 4000 roll number. 4000 roll number. That is 13. And 4000 next. 4000 next is null. Null is assigned in the temp. Null not equal to null. Condition false. It will come. Getting right? Suppose if I give temp next not equal to null,
It will skip the last null.
it will not print the 13. So it will print up to 12 only. Got it, right? So in case of display, you can have temp not equal to null. But other case like you can have temp next not equal. You have to understand the difference. Okay. Fine. Display everybody clear, right? Okay. Fine. So the sequence you write. Next to the pending one is delete. So it means whenever user is giving the choice as a delete, we want to delete the last node. Got it, right? So whenever, suppose let's take this scenario, when you are deleting this node, so what and all you have to do?
You have to traverse until null.
Very good.
Yep.
So you have to traverse till you are finding the node temp next as a null. So after that, okay, traverse, then
Then you deallocate that last null.
very good. Because this is dynamically allocated memory, you have to deallocate. You have to free the memory. That is second thing. Traverse, free the memory.
Before the last element next node, you have to make it as null.
Okay, very good. So now this node is deleted, then this will be the last node. So last node means how we can indicate? In this place you want to assign the null. So these three things you have to do. One is traverse, deallocate the memory, and the previous node next pointer you want to make it as a null. Okay. So let's see how we can do this. So that will be case 2. You guys write it in an order, that is you follow any order whatever it is. Okay. So case 2. So anything when you want to delete the linked list, first thing is what you want to do. No. What I'm saying? No. Like here, whenever you are trying to display, first you are checking in the linked list at least one node is there. Then only you can display. The same way, delete also, at least one node is there, then only you can delete. If no nodes are there, then you cannot delete, right? First you want to confirm. If head equal to null, then printf list is empty. Okay, so people will understand. If they by mistake they given on an empty linked list a delete option, they will get the message that the list is empty. Okay, that is fine. Now let's take the other scenario. If list head is not null, if it is going to the else case, It means you must be having one node, or you must be having 2 nodes, or 100 nodes, or 10 nodes. We don't know that. But we want to delete the last node. Is that clear for everybody?
Yes.
Okay. Now, this delete, you have to handle it in an efficient way. Otherwise, like, it will confuse you. You will end up with like lot of confusions. So what we will do is, we will handle it separately. It means, if you have only one node, getting right? If you have only one node, let's assume this is the only one node you have in your linked list. How will you identify you have only one node?
Then
Head not next equal to
Head,
not next equal to null.
head next,
Equal to null.
next.
head next is null means you have only one node. See, head is 1000. 1000 next is, as of now 2000, but 1000 next is null is there. Then what it means? You have only this node.
Only one.
Clear, right? So just that we will handle it separately. Okay. So here, if head arrow
Next.
next equal to null means you have only one node. That node you are going to delete. Okay. So what we can do next? So you identified the node which you are trying to delete. That is head node only you are going to delete. So tell me how we can delete.
Free
Free
head.
head, okay,
Head equal to
and then
head equal to
head equal to null. Very good. That's all. Okay. It means head was pointing 1000 and the 1000 next was null. So what you have done? You have identified that the 1000 next is null, and you are freeing the 1000. That is, this memory will be free. Also, in this head pointer, you assigned the null. So only one node was there. That node was deleted, and now your head pointer is pointing the null. It is perfect. That is what you want, right? If no node is there in your linked list, your head should be pointing null. If no node is there in your linked list, head should be pointing null, right? So it went back to the same situation. Okay, that is perfect. Next, you have only 2 nodes.
twice.
Okay. Okay. Now let's assume that like a one node be deleted. Now assume that you have like a 4 nodes. Got it, right? You have a 4 nodes. Now you want to delete it. So what's the like a thing like we have to do it now?
We have to traverse till last.
Traverse till the last node. Okay. Now here I should use one else. Got it, right? So I am going to use one else.
Node is of if only one node is present, then only if condition will come.
Correct.
If more than
So
one-
if it is going to the else, it has more than one node. Then what we are doing, temp is equal to head and while temp next not equal to none. Temp equal to temp next. Okay. You just take this traverse. Okay, let's take this scenario. Head is 1000, right? So 1000 assigned here. Got it? And 1000 next 2000. 2000 not equal to null. It is going here. 2000 assigned in the temp. Again 2000 next. 2000 next. 3000 not equal to null. Going here. 3000 will be assigned in the temp. So temp is moving here. Again 3000 next. 3000 next. 4000 not equal to null. True. it is coming here. 4000 next. Sorry, 3000 next, 4000 is assigned here. 4000 next, 4000 next, null. Null not equal to null. Condition failed. It is coming out. So now temp is having 4000. Now which node we want to delete? The last node. That is temp node we want to delete. So how we can delete? Free temp. Okay.
Outside the else we will write or inside the
Outside. See, this while loop is only to identify the last node. Now we identify temp is the last node. We are coming out, we are freeing the temp. Now after that, temp equal to null. Okay. Is that done?
we have to before previous second last also we have to change the address next step. Change the
Okay. How to assign the null?
We lost that address.
second last.
Okay. So far what we have done is like this memory we freed.
But we will have
But
four
we
from-
want to assign null here. How to assign null here? Okay. So with this method, obviously it is not possible. So then what we have to do is we have to like do this way. Temp next not equal to null. Okay, now let's go the same the discussion from the beginning. Head is 1000, right? 1000 is assigned in the temp. 1000 next is 2000 next is 2000. Again, see, look at here. This is 2000. 2000 next. 2000 next is 3000. So as a overall, this will be 3000. So 3000 not equal to null. Condition? True one. So true, it is coming here. Now 1000 next. 1000 next is 2000 updated to the temp. 2000 next. 2000 next is 3000. 3000 next. 3000 next is 4000. 4000 not equal to null. Condition? 4000 next not equal to null. Condition true only. It is coming here. Now temp is 2000. 2000 next. 2000 next is 3000. 3000 updated here. 3000 next. 3000 next is 4000. This is 4000. 4000 next. 4000 next is null. So condition failed. It will come out. Now temp is pointing back. 3000. Temp is here. See, previously temp is here. If we give temp next not equal to null, temp will come here. If we give temp next not equal to null, temp will be pointing here. Okay, now we are stopped here. Now we want to delete this. Is it possible? How to delete? Free temp arrow next. Okay, then temp arrow equal to null. See, temp is 3000. 3000 next 4000. So 4000 memory you freed it. It means this memory is released. And also temp next. Temp is 3000. Temp next here you assigned a null. The job is done. Is that clear? Okay. but still there is one small problem. Yeah, so far whatever we discussed, it is okay. Let's take one more scenario. You have only 2 nodes. Okay, you have only 2 nodes. 2 nodes means like you will have null here. Am I right?
Yes.
Okay, you will have a null here. So assume that you have only 2 nodes, and 2 nodes means like this condition will be failing. It will go to else here. This condition also will fail because head next is 2000. So this condition also fail. It will go to here. Now 1000 you are assigning. 1000 next. 1000 next is what? 1000 next is 2000. 2000 next. Null. Okay. So null not equal to null.
Is
Condition false. So it will come out. Now free. Okay. Free temp next. 2000 you are freeing, right? Okay. I think yeah, it's not a problem. It is working for that case also. But okay, if it is single node, we already handled here. If it is more than one node, then it is handled here. Yeah. Okay. So sorry. Actually, I was supposed to. I mean, generally like a previous classes and all, I don't discuss this. First, I will discuss this and then I will come to this. Okay. But now already I discussed this so that it is clear. So hope everybody clear, right? So if one node is there, we are deleting here. If more than one node, we are deleting here. That's all.